probably. Let's start with a simple one. R equals A cosine theta. Please remember, and also R equals A sine of theta. So whenever you see something like this, well, for instance, R equals 2 cosine of theta, or R equals 3 cosine of theta, please remember, you are going to get a circle. It's a circle, for example, in this case, when it's cosine, your circle looks like this. And by the way, A right here represents the diameter of your circle. Okay, so the distance, this distance equals to A units. Now, when it's R equals A sine of theta, again, A is the diameter of the circle, and also it is a circle, but in this case, it's tangent to the x-axis, and again, this distance is the diameter, and that equals to A. So the diameter of the circle that has its bottommost edge at the pole. Okay, all right, next. The second type of polar equations look like this: R equals A plus or minus B sine of theta, or R equals A plus or minus B cosine of theta. Obviously, A and B have to be greater than 0. Some kind of numbers, and we're gonna play with the equations, and I'll show you how to graph. But right now, I just want to make sure you remember what those equations look like and what the shapes are. Now, very important, when you have these two, it applies to this one and this one, okay? As long as you have A plus or minus B, sine or cosine of theta. Now, you need to consider this ratio, A over B, okay? So you're gonna focus on this ratio. Now, if A over B is less than 1, then you're gonna get the shape. You know what? Let me erase and make it a little bit longer. So you're gonna get this kind of shape, centered at the origin, and you're gonna see this little loop, inner loop, and it touches the origin. Okay, so that you get when it says R equals A plus or minus B sine of theta. Okay, and this condition is very important. So if A is less than B, this is it, and it's A plus or minus B sine of theta, then you do have that inner loop and centered at the origin. You're touching the origin. Now, let's say we have the ratio as our ratio, A over B, a 1 equals to 1. So that means A and B are the same. For instance, R equals 2 plus 2 sine of theta. So if your ratio equals to 1, then you're expecting to get a heart-shaped graph. It looks like this, and also it contains the origin as a point, one of the points, okay? And next, if A over B, again, ratio, the ratio is the value of that equals to something between 1 and 2. So 1.2, 1.3, 1.9. Then you also get the heart-shaped graph, but it doesn't contain the origin. So it's going to look something like this. So we're not at the origin, okay? Now, there's another scenario when you have A over B that is greater than 2. Then you're going to get, again, a graph that looks almost like a circle. Looks like a circle. And again, has nothing to do with the origin. That's not part of your graph. Okay? Now let's talk about the next family. R equals A. And I remember when I started this lecture, I started with these equations. R equals A cosine of theta. And a coefficient next to theta is an invisible 1. And I said, in this case, you just get a circle, but the diameter equals to A. Now it's going to look pretty much the same, but, oops, the difference is I do have a certain coefficient next to theta that is greater than 1. So let's put n times theta. So please focus on this n. Or R equals A cosine n times theta. All right, so if you get something like this, for example, R equals 2 sine of 3 theta, or R equals 5 cosine of 7 theta. So then you are expecting to get, you're not going to get any circles, you're not going to get any heart-shaped graphs, but you're going to get a certain number of petals. So it looks like a flower, actually. So please remember that. And here's the rule. If n is an even integer, and you're dealing with R equals A sine of n times theta. Now let me write it down. If n is even, then we call it the rows. The rows petals graphs, okay? So if n is an even integer, then the rows will have 2 times n petals. This is very important. So, for example, R equals, let's say I don't want to use the number, but sine of 2 theta. Then you look at this integer, it's 2, double it, you get 4. So therefore, you get 4 petals. And when you graph, you get something like this. Now, you noticed that each petal is located between the axes. So one petal is in first quadrant, second one is the second, and third and fourth, and so on. So, but they all meet at the origin. That's important. Now, if let's say you're given r equals a cosine of, I don't know, 4 theta. Same process, you multiply it by 2 because n is even, you get 8 petals. But when it's cosine, then your petals, one of them is right on the x-axis. The other one is on the y-axis. We don't really call them x-axis and y-axis. I'm just using these terms so that you can understand me better. And we have 8 petals. So another one is in between. Another one is between. So 1, 2, 3, 4, 5, 6, 7, 8. So you get a rose with 8 petals. Next, now what happens when n is odd? If n is an odd integer, then the rose will have it's gonna have n petals. That's it. So you don't double it. You double only when your n is an even number. So for instance, if you have r equals a sine of 5 theta, 5 is odd. So that means we're going to get 5 integers, and it's sine, so we're not on these lines. So it's going to be something like, well, it depends actually. But this one is in between, well, it's in the first quadrant. The second one actually is right on the y-axis. The third one is supposed to be somewhere here, and here, and there. And then I'm going to teach you how to sketch it. But right now I want you to remember these rules. Very important. Otherwise you're going to have a hard time graphing. So, or r equals a cosine of 3 theta. Okay, so we're going to have 3 petals. So one petal is going to be right here, just like in my previous example. And the second one is here, and the third one is there, and they all meet at the origin. Okay. Finally, another family of polar equations, graphs. You're not going to see that much on the AP exam, but you do need to know what it looks like. So if you see something like this, r squared, not r, just r squared, or r squared equals a squared cosine 2, by the way, 2 theta. Obviously a is not equal to 0. Then you always get an infinity kind of shaped graph. So you remember what an infinity looks like. So it's like 2 petals, or I would say a number 8. Okay. Now for sine, your infinity symbol is going to look like this, and always 2, okay? So it's a number 8. And for cosine, it's going to look like that. So this you need to remember, okay? So this video just shows you the basic rules. And actually, I already posted a chart with these rules on Haiku. I think it's under notes or videos. Take a look, please. So you do need to sit down and memorize it, because you're going to have a very hard time graphing the polar equations, and you do need to know how to do it in order to find the areas. So the second video, I'm going to show you some examples.